Welcome back to our grade 10 maths lessons. I am Miss Aunup, your maths teacher. In our last lesson, we looked at inequalities and how to show inequalities on a number line. In today's lesson, we are going to solve, all right? We are going to solve inequalities by calculation, okay? Excuse me, inequalities. All right, so we're solving inequalities. Now, if we are to solve an inequality, remember all equations follow the general equation y equal to mx plus c. For inequalities, the equal sign is replaced by an inequality symbol. We've looked at that already. We have less than, greater than, less than or equal to, or greater than or equal to. Okay, so when we are solving inequalities, I'll put one example up here so you can have a look at what I mean. 3x plus 2 greater than or equal to 7. When we solve inequalities, what we do is solve it as if it were an equation. What happens here is we are trying to find the inequality statement, the simplest inequality statement that will give us a range of x values that will satisfy this inequality here. Okay, so let's try doing this. Again, you are using the skills that you learned for solving equations. So if I take positive 2 across to that side, it will become, now this is negative 7, so I forgot that. We take positive 2 across, 3x becomes greater than or equal to negative 7 minus 2. Okay, your inequality symbol remains the same. So 3x greater than or equal to negative 9. Okay, and to find x, we are going to divide by positive 3. So x is greater than or equal to negative 9 divided by 3. And your solution is x is greater than or equal to negative 3. Okay, so your range of values greater than x give you all possible solutions for x. Okay, so again, you can put this on a number line like what we did in our previous lesson, okay, where we have negative 3. Let's see very quickly. All values of x which are greater than or equal to negative 3. Okay, so what we are doing here is not actually solving for a specific value of x. We are looking for the inequality that will give us a set of x values that can be a possible answer for this inequality. All right, so let's go on. There are 3 rules that we must remember, okay? Those rules, and I'll be very quick with this. If we have, or if we add or subtract, all right, a positive or a negative number, okay, the symbol here, this symbol here remains the same, okay? We are going to look at examples to show this, okay? If we multiply, all right, or divide by a positive number, again, the symbol will remain the same. However, the third rule states that if we multiply, okay, or divide by a negative number, all right, the symbol will be reversed. Okay, symbol changes or it is reversed. Okay, now let's look at a couple of inequalities to see how the third rule is applied. Okay, so let's see 5 greater than 3. Okay, that rule is true. 5 is a number that is greater than 3. Now, if I multiply both these numbers by positive 2, okay, it will give us an equivalent inequality. So 5 times 2 will be 10. Okay, greater than 3 times 2 is 6. That statement is still correct. 10 is a number greater than 6. Now watch if we multiply this inequality by a negative number. All right, so we'll go times negative 2 times negative 2. Okay, what happens? This is negative 10. Keep the sign and let's see. 3 times negative 2 will give us negative 6. Now, negative 10 greater than negative 6 is not true. Negative 10 is a smaller number. That is why this symbol here has to be reversed. So our inequality now should correctly be written as negative 10 less than negative 6. Okay, so keep this in mind when we are applying the third rule. Okay, so we go on to example number 2, and we are going to show how to apply this. Okay, we'll start with an easy inequality and from there move on. So let's see, negative 3a is greater than negative, greater than 12. Okay, so again we are applying equation skills or solving equation skills. So we have to divide this by negative 3. Go back to the rule. When we divide by a negative number, the symbol changes. So this greater than symbol now becomes a less than 12 divided by negative 3. So a is therefore equal to, a is less than negative 4. Okay? This is how we apply the third rule. When dividing by a negative number, the symbol will be reversed. Okay? Let's look at one last example. Okay? Here we have a over negative 2 less than 4. Okay? Now, in order to find a, we have to remove 2 to this side. So we are going to multiply a. Okay, your symbol here is now greater than 4 times negative 2. So a is therefore greater than negative 8. All right? All right. Now that's the end of our lesson. Okay? We've looked at solving the inequality. Symbol remains the same when numbers are positive, but when you multiply or divide by a negative number, the symbol will change to the opposite. Okay, so you have examples that show that. I hope you've learned something new. In the next lesson, we're going to see how we can put these inequality statements and translate it into a graph. Okay, I'll see you next time. Hope you can join me.